So this is also special for me because this is actually the first virtual talk I'm trying. So let's see how this goes. But I'm happy that I had a chance and I would ask. So I hope you see my starting slides. So this is about embrace change. The idea of this talk, I got at work. So I'm working at SoundCloud. We are like roughly like 20 Android developers working on the app. And I realized at some point, like when although we have really experienced developers and they use Kotlin for quite a while now, I realized at some point, like, but they're not taking Kotlin like to the final edge sometimes. I was wondering, why is this? I mean, these are smart developers and they love Kotlin and they do this for years now. So I started a bit digging into it, and how it happened, a talk came out of this. And I wanted like to understand, not only like show you like what I think you should use more in Kotlin, but also why I think some of us are not doing this. We start really in the beginning. So we start with evolution. So when you think about how humanity evolved, like new things were always something dangerous, right? When we think about back in a time when we lived in caves, the new things could have been dangerous. And this is because we have like ever since we have this threat detection system. So everything that is new, that is unusual, that is unknown could be dangerous. I mean, that's what kept us alive like millions of years, like back when we lived in those caves. And interestingly, this somehow still is wired in our brains, right? This threat detection system. This where some of us hesitating to go into new things, to step out of our comfort zones. Which brings us to a very interesting book I found. It's called Mindsets. And what I found there, I found really interesting, because when I started with Kotlin, I think it was 2016, I started like writing the first blog posts about it. I loved it. And a lot of developers that I talked to loved it too. And I was really surprised that there are actually a few developers out there that were hesitating. They did Java for a long time, so did I. But they didn't like Kotlin. They didn't want it to go there. And I was like really surprised to see this and to see this back pressure that came there, right? And actually this book, Mindsets, actually explained this a bit. So the author basically says that we have basically can put our brains into like two categories. There's like something like a fixed mindset. If you have this, then like getting out of your comfort zone is really hard for you. You don't really like acquiring new skills. And I'm pretty sure most of you, because you're on this talk, you spent your Saturday learning about Kotlin, you have more like the growth mindset. That's what the book called it. So you have a certain amount of curiosity. You want to explore things and like solve difficult problems, right? So I like this. Like sometimes people ask me, why do I change jobs like every 2 years? And it's most because I want a challenge, right? So I realized, okay, maybe I'm more of this growth mindset. That's what is really interesting. And now we can put this back to Kotlin, right? So many of us started with Java. I did it like for 10 years before even thinking of moving to Kotlin. So there's this big Kotlin hill, and we want to get up this hill, and we're starting from our Java skills. And it's very easy for most of us, right, to start, right? Like the first steps are easy. We convert like Java code to Kotlin, and then we learn about nullability. And so the first step are very easy, right? I mean, yes, there's some Java-ish, Kotlin code that we write, right? But at some point, we reach a really good level. The start is very easy. Because the way learning works is actually very interesting. We always learn from like referencing what we already know. So the brain likes to find similarities. And that's also why in the beginning our Kotlin code looks really, but it because it's not that far off Java, right? I remember when I looked at Scala and it was a bit too far for me. So that's one thing I like with Kotlin. So at some point, you're somewhere on this middle of the hill. So you're writing Kotlin for a while now, for production code. You like Kotlin. You're completely convinced that you're a good Kotlin developer. But what if I tell you that you're very far off that hill? And I would even get further. What if I tell you that the things that got you here, in this place where you are right now, will not get you up there? And this is kind of because we always, what I just said, this referencing to the past and what we already know. And actually, if you remember KotlinConf last year, there was a talk by Christina Lee. I think it was called Testing. And she had this graph, and she said, if you only use Kotlin with the same features that Java had, you're just writing a new language, but you're still on the same step, this Java step. You didn't make it up there. Like the same philosophy that I tried to build with this hill. So you really have to think about this Kotlin functionalities, things that Java did not have. So the question is, how do we get there, right? And let me put this with Charles Darwin. So it's not the strongest species that survives, he said. It's also not the most intelligent one. It's the one that adapts to change. And you can translate this to developers, right? It's not an evolution. So things change a lot. I used to be a BlackBerry developer. I had like a BlackBerry certificate. It's not worth anything, and this is only like 10 years ago, right? So things change, right? So it's not the best developer that will survive, but the one that can adapt the best to all these new things. Let me show you something. Let's talk about programming. This is a snippet from Pascal. This is the language that I started programming with in the 90s. I don't remember this, to be honest. I had to look it up in Wikipedia. But this is the syntax. It actually looks very Kotlin-like, right? And then came, historically wise, like C and C++. And look how we changed the order of the naming, right? We put the type first. There's a really interesting blog post by someone from JetBrains, I don't remember who it was, about why Kotlin changed this and why this was in history like this. Java adopted the same principle, right? Type first. And now we are back to kind of where we in the 70s. We put the type second. I mean, there's a reason for this change, type inference. But it's interesting, right? And developers adopted to this. We are very flexible. That's fine. We liked it back then. We got it. We liked it in C. And now we prefer the Kotlin way, and we didn't even understand why it was ever different. And this brings me to another quote, and then we'll dive in more into Kotlin. Here's this guy called Alvin Toffler, and he talks about the illiterate. If you don't know about illiterate, these are the people that cannot read and write. And he said, the literate of the 21st century, so where we are now, will not be those who cannot read and write. It will be those who cannot learn, unlearn, and relearn. So similar to Darwin, right? He said, it's about adapting. So the ones that will make it to the top will the ones that will be able to learn, but also unlearn and relearn. And that's what I focus on a bit. So unlearning some of the Java pieces and relearning the Kotlin way of doing things. So let's talk about something simple in Kotlin, constants. Sounds simple, right? We all know how constants work. In Java, they were static final. In Kotlin, it's a const val. And probably we can all agree on this. But then the first question arises, where do we put them? In Java, it was easy, right? You had something like an interface maybe where we put all your constants. That was easy. But where do we put this in Kotlin? We can have something like this. We can also use an interface, but then we need to put it in a companion object. Companion objects are actually something that developers use a lot to put their constants in. But why not something like this? Why not use an object? This is more actually what we had in Java, right? But I hardly see this, like a singleton, but the Kotlin way. And what prevents you from doing this? What prevents you from putting your constants top level? And a lot of developers, when they move to Kotlin, this somehow feels wrong, right? Because we learned like top level constants are something bad. Like there was a reason Java did not allow this, right? So this feels wrong. So when I thought about this, I asked around a few weeks ago. So 1,500 people gave a vote. And it seems most people use the companion object, which was a surprise for me. But what I liked is that a lot of them in the comments section said, I used to use the companion object, but I moved to top level. So I think there's like an evolution there. And the same was for me. And one of the reasons that companion objects always look a bit ugly. And I think JetBrains made this on purpose. It's like the exclamation mark, right? It should warn you, like, is this the right thing? Because making them static is the kind of like the Java-ish way of doing things, right? So don't be afraid to put them top level. There's actually a really nice blog post also, I can send it later if you're interested, telling you that companion object and putting your constants there comes with a price. there's a lot of code behind it that you will not have if you use top level. So there's a reason they put it top level in Kotlin. Don't be afraid to use it, right? They can be private. Most of my constants are private. And I mean, if you remember my Kotlin conf talk, I hope you saw it about types. Maybe we shouldn't have those constants in the first place. So it's time to unlearn some things. This will be the message here. So what means unlearning? Unlearning does not mean forget what you know. This would be wrong. It's more about finding a new alternative model to understand things. You don't want to forget. I don't want to forget Java. Like Java made me where I am right now. But we have to switch the view a little bit. So in your science, there are like 3 parts of positive unlearning. First, we have to recognize that the old model doesn't really fit anymore. I think that's what I'm going to show. Some of the Java things don't really fit in the Kotlin world. So maybe the first one is easy. But be aware, like, you have this unconscious bias that will always tell you that it's the same thing. The second is create a new model in your brain. Also be careful here, because you still have this, you're looking to everything to the lens of the old model. So creating a new model is not as easy as you might think. And the last part is the most easy one, the most important one. Train, ingrain these new mental as habits. Habits is what drive us. I give you an example. Functional. When you look at functional programming, this was there before object-oriented programming, but it gets this huge revival in the last year, right? Like with even in Java world, with like RxJava and all these reactive streams, things all of a sudden got functional. And if you had code like this, like assume we have think of SoundCloud, we have a few playables and we want to find all the tracks, we could have something like this. And a few years ago, we would have written it like this. Have a for loop, iterate over them. If something's a track, adds it to this other list. I mean, nowadays, most developers would write it something like this. Use like a filter. This is a very functional approach. And although Kotlin is an object-oriented language, they support a lot of these functional aspects, right? But thinking of functional and moving toward functional, and I remember this when Java came, is not easy. It's a complete shift in your brain, right? Going from imperative to this more functional approach. And whenever I do like a coding cutter, I love TDD, so I try to do coding cutters. I always start with for loops, so because I'm so into this. I did this for 20 years, right? So with this, I want to show you how hard it sometimes is to get into this new mindset. So although we know there is something that often fits better. And this was recognized a long time ago, like Dijkstra, one of the heroes of computer science. He said that the tools that we use have such an influence on our thinking and our habits. He actually said really bad things back then about BASIC and COBOL programmers. He basically said they're completely lost souls. They can't teach anything else. I don't think it's for the Java developers to Kotlin. It's like they're much closer. But still, the languages we use, the tools we use, they made us where we are. And they influence our thinking a lot. Let me give you another sample. Operators. When I first looked into Kotlin, I thought, really, operator overloading is back? I didn't miss it when I went from C to Java, from C++. Why is it there? Like, I don't know. It felt wrong. There was a reason Java didn't hit them, right? So how often are you writing operators nowadays? I think a lot of developers have this thinking that I had in the beginning. And this is because when you think of operators, we normally think about the plus operator or compared to maybe the range one, which is a bit cooler, right? But you think about the classical operators and you think, why should I overload them? And most developers never overload an operator, although they use this. Let me show you one, the invoke operator. So this is a piece of our code. Assume we have these bottom sheet menus and there's a little header on top, so the bottom sheet header. And this thing is for users, for tracks, and for playlists. And we have these operators who build these headers. Let me show you how we use them. These are invoke operator overloaded. So we have a function called hey, load the track header. It gets a URN, which identifies a track. And we would load from the repository the actually track info. And then we just call this mapper. So the mapper gives you this bottom sheet, right? sheet header. So why is it just a mapper, right? You hardly see that there's an operator there. But it does not say mapper.map, which is probably what you use in Java, because that's completely ridiculous and redundant information. Don't call it mapper.map. Use an operator here. And it's very different from the way we used to use operators. So think about this. This sample here I had at Kotlin Conf. So we still get it. Look at the last line. So this looks like I'm creating a class, an instance of clap user URN. But I'm actually not. What I'm doing here is calling an operator that is in the companion object of that class. And the idea was I want to only create valid users here. So I want to have null if the ID is not a valid one. I don't want to have something, we want to get rid of ID not set or -1 kind of things that we had before. So you can only create these things, and we don't want to throw exceptions. We want to have this compile time safe. This is how you can use it. So it looks like a constructor, but actually you have to make sure it's not null, and then you go on, right? So this is so Kotlin. There's no way you could do this in Java unless you've read a lot of ugly code. So think about these. This looks like crazy, but think about these kind of things. Now the question is, how do you get there, right? And I found this one. That's the University of Haifa. Haifa, I think, right? So development of an original or a creative idea needs like 2 simultaneous activations in your brain. And actually it's contradicted in networks. So you basically use what they call like the associative, so more the spontaneous part, because it's an idea, but you also need this conservative part. So both need to be active at the same time, and then you actually have a creative idea. What I found interesting with this one, when I read this, that I remember that someone told me about innovations. Like nearly all the innovation that we had over the centuries, they always came when 2 fields came together they were independent of each other before. And this is how innovation starts. So you need 2 complete different fields. All of a sudden they talk to each other and they realize they can solve this problem together. And this can be put back to the brain because it's the same way in the brain. Which brings us to the question, what goes on in the mind of a programmer? Do you ever ask that? So I guess some science did. So there were 2 studies, one in 2014 by some German universities, and then one that just recently built on top of this. It was just published this year. What did they do? They basically wanted to know what happens in our brains when we read code. So they put developers into an MRT and checked their brain and gave them code to read. That's what they did in the first study. Some criticism on the first study, because when we read code, we do 2 things. We're trying to understand it, and we're kind of checking the syntax, right? So in the second study of the University of Chemnitz, they subtracted this from each other. So they first gave you code to figure out what it does, and then I think 10 times they gave you code just to find syntax errors. And this way, they could subtract these areas of the brain that just check for syntactical things. Interestingly, both studies came to the same result. To their surprise, they did not saw any activity in our brains that are in the areas that we use for mathematical or for logical thinking. This is super interesting because we always think this is like the 2 things that like developers need, right? Not when we read code. We don't need these parts. This brings us to like what is a developer, right? Like in the beginning, it came from computer science and like from math. Computer science came from math, but they diverged very, very early. And ever since we're trying to engineer, they realize it doesn't really fit as different things. Is it an artist? We have a creative. Like I'm part of like a software crafters. Like this is more like a craftwoman thing, right? So, and this could be put back to the brain. So maybe it is not the logical and mathematical as we always thought it is. What they saw is that the areas of the brain that we're using on the left part of the brain, and they're normally associated with speech comprehension, with languages. So what I hope is that this will influence the next computer language design. If we know that learning Spanish is very similar to learning a new programming language, maybe we can make these new languages better. Which brings us to names. So I look up COBOL, because it's one of the oldest things we can think of, and checked what are the restrictions on naming for COBOL variables. And according to Wikipedia, you can use any uppercase character, some digits, A hyphen is allowed, just not in the beginning. And when I read this, I thought, this is very similar to Java, like up to Java, right? Yes, we have lowercase and we have, I don't know, an underscore, but the digit cannot be in the front. Like, it didn't change that much. All the COBOL is so many decades ago. And that's very interesting. So now with Kotlin, what prevents us from doing this? Naming a variable user database ID to be modified. I mean, we know, most of us know that Kotlin has this ability, right, to name variables like this. But we only use it when we're trying to write DSLs. I mean, some of us use it for testing, but that's it. Why are we limiting ourselves? What's wrong with this, right? I mean, I don't know any developer who names a variable like this. And I think for a lot of us, this is because something inside us like cringe, something, I don't know, doesn't feel right here, because that's not what we know. And this is why this cringe is. And this is very interesting. You know, what happens in your brain is for these like social missteps, everything that is not as it's supposed to be in your social area, it activates the same region of your brain that is associated with physical pain. So reading this code I just showed you might create actually physical pain, and that you feel uncomfortable with it. But there's no actual pain there, right? You should be aware of this. There might be a reason why we don't want to use it. Doesn't work on Android. But still, we should think about it, not discard it in the first place. And I think this is one of the first messages here. When someone expresses an opinion that is not your own, take it as a chance to grow. I mean, if you follow me on Twitter, you know, like I can be very negative sometimes. And we should not, I should not, right? Be curious and not always be defensive. And that's something we can adapt immediately in our daily work, right? So, and the interesting thing is when we started to be open to new ideas, we practicing unlearning at some point. And every time we practice unlearning, it will much easier the next time. This reminded me, so when I started Kotlin, I thought it was 2016, I think, or 15. I loved it. But I haven't looked at any other program, actually probably for 10 years. I didn't look into JavaScript ever. I found Scala interesting, but I never really looked at it. But after I learned Kotlin, I started to be curious about others. So when a chance came for Groovy, I wanted to look into this Groovy code. This Groovy backend team. And now at SoundCloud, we use a lot of Scala. So every time you're opening to something new, the next time it will be even easier, right? You will be even more this growth mindset. That's very good to know, right? So let's go back to code. Let's talk about properties. So most of us write code like this. So when we have like a class with a field, and then we write like a getter for it, right? So this is a very Java-ish way of doing things. Oh, doesn't have to be Java, right? Like a lot of the languages before. What prevents us from doing this, from making this field public? So maybe you're doing it, but I know a lot of developers don't. And I remember when I talking like many, many years ago, when C# started to have these kind of properties, it had also like delegates. I was arguing as a Java developer, oh my God, you cannot make this field public. This is just wrong, right? And he said, no, this is not violating encapsulation here. I know what I'm doing. So this was a language feature, but I didn't understand it. Now with Kotlin, this is the way I'm doing it. And this makes even more sense when you think about interfaces. And I hardly see any developer doing this. So if you have an interface, not only define functions there, define properties there. I'll show you why you should. Because there are so many ways you could implement this. And this is exactly what you want. You want a lot of freedom. So you could implement it like the way you probably think about this. Override this one. Or you make it a constructor argument. Think about this. So this is the same implementation. And I use this way a lot. This also helps us when you think of like injection and not injected. You can always have something like this. You can have like a delegated function that actually retrieves it from something else. So this is why you maybe in the first place want to make it a function in your interface. You still have this freedom. It doesn't have to be a static property, right? You can have a custom set for this if you make it a var even. That's a cool thing. You can implement a var as a var, and only if someone knows the actually class that implements it or internally, you can actually set it. And then you can have something like a side effect that, I know, change environments when you change this URL here. And this is just possible because we just declared a val in our interface. And there's so many possibilities. And to be honest, properties are just starting here. Let's talk about delegates. And I hardly see anyone actually. You probably used by lazy, right? Probably use it daily. You probably have something like by inject if you ever played with Coin. Maybe you're an Android developer, use Jetpack, you know by view model. So have you ever either looked and what is behind this by? What is by view model? Or have you written your own? Most developers haven't. I gave a full talk about delegates, but let me just show you quickly what. So normally the first one is a function, my delegate. Like lazy is just a function. And that returns you a property. And there's a class to implement this, either a read property or read write property, depending if there's set or not. It's not completely true. You can actually do it without and just have an extension function for the set and get, like lazy is implemented like this. But it's basically something that has a get and a set value, which is very similar to the way you would write it without delegates, right? There's no magic there. Let me show you some delegates that I used in the past. So we had something like this in my last project. It was a toggle on first access. So this variable is false. And once we actually check it, I think we use this in view models, it was not initialized, subscribed to some store. So we had some kind of MVI approach here. At the moment I check this, I touch this variable, it toggles to true. So it never be false again. And this is completely atomic. So we, in the beginning, why we started to have this delegate, we had these atomic booleans all over the place, and they look so ugly. This is how we solved it with these delegates, and it looked beautiful. And behind it is just an atomic boolean with a getter value. And then we start into more things. Maybe you know in iJava the disposable interface, which is just an interface that has a clear or like a dispose method for clearing things up. So we had something like a by disposable. And every time we would assign it something that has a disposable to this variable, we would dispose the previous instance. So we don't have to think, oh, if it's not null, dispose it, right? And we could even use this, like in here in undestroy, we set it to null, which looks very C-like, to actually clear up this value and this variable. And then we started to use it for other things that are very Java-like. We had this thing called an observable. There's actually one built in Kotlin. This is not this. We had our own. And what we could do is just like a do or next. So whenever you assign something here, for example, it would be a string, we would also trigger, for example, the search of the use case, because this was a query variable. You might think, hey, I can write it like this, right? It's the same thing. It's actually the same thing. But why we use the delegate? Because we had much more functions that we could chain on each other. So this one we had on a video player. So we wanted to know, or we needed an event when an ad is starting or stopped. And the player actually gives you like constant feedback. But I'm only interested when the value changes. So at playing true, I don't care about, right? So we had this distinct until change. We could only propagate downstream if it's changing. And then we had a do on true and do on false. And then we had our callbacks. This reads really, really nice. And it hides a lot of ugliness. So property clearings are very powerful for small things. Here another example that I just introduced recently. When I was working on edit profile, so on the app you can change your profile avatar or have like a nice banner. And of course you need temp files on your Android phone, right? Like where you put the image and then you start cropping and all of these things before you upload it to the server. And I need to make sure that I delete previous temp files. And I did the same way, like this is a read write property. And every time I set it, I call this delete. It's easy. So whenever I assign a new field to temp file, the previous one will be actually deleted on the file system. And I didn't have to care about this anymore. Which brings me to another thing that a lot of developers are kind of afraid of when they move to Kotlin: extension functions. Like especially in the beginning, there is a lot of like pushing against this, right? Oh my God, you will pollute your namespace and you don't know anymore, and everybody will have these public functions. This is very similar to what we talked about constants, right? I use extension functions a lot. Most of them are actually private, and I show you some things why I think they are really useful. One I wrote a blog post about recently. So we had something like this. We have like feature flags, so we can enable things in a debug app, for example, or in internal builds while we're still developing them, when they're not ready. So there's something like is enabled on the feature. That's the interface. So there's an implementation, for example, with Firebase feature flags behind it. But I realized that a lot of parts in the code, we had something like disabled, and this looked ugly. This is disabled. And I thought about adding it to the interface. But then I realized that I will break a lot of things with this. Every time we would mock this interface, if you call is disabled, although it's just the inverted version, things will not work. So you have to mock it everywhere. And also, like, it's an interface. So this is something that I put on a blog post. There is like a dependency between the function, but you cannot express them in the interface, right? So what I did instead is create an extension function on the web features on the on that interface in the same class file. Here's an is disabled. The nice thing is this will work with all your mocks, with ever. The interface is super clean, but you have the chance of use either is enabled or is disabled. So that's like a way that extension functions are not used that often. For these interfaces, they are brilliant, to be honest. And there's another thing where I use them a lot. And I can explain it with something from clean code. There, Uncle Bob had something that he called conceptual affinity. He said certain bits of code want to be near others. They have this certain affinity. The stronger the affinity, the less vertical distance there should be between them. And we can use this principle from clean code, which was based on Java, with extension functions. So lately we had this. I think it was a Kotlin script. So we tried to use Kotlin also for scripting files, where find line numbers of a test case in a file. And it would run probably like from here, like all the lines that are in that file belonging to this test case. I don't know what the context of this was, but we had this function. And then I commanded on this pull request with, why not write it like this? In this file, I want to find the line numbers of this test case. So the affinity to file is much higher. Why put as a second argument? So now it's something that you call on a file. And you can also nicely overload this. This reached much better. And this is what I use extension function a lot for, just to improve the readability of things. Another thing that we had in this script was something like this. There was like a regex, need to find something, and then probably looks like something with Git. So there was like a hash and author and the date. It's like the first, the second part, and the third match in this group. And I suggested, like, if this would be used more than once, I would write it like this. I would create extension properties on this match result, but keep them locally so that no one else sees them, because they're bound to this context here, right? So there would be a hash, an author, and a date. And you can directly call them on the match result. So it looks super nice, even if you have a few lines to write here when you use them. Again, extension function help you when you write the code. So how do we get there? You probably have to think a bit outside of the box, right? But the question is this even possible? Let's ask neuroscience. So when you look at neuroscience, it's basically impossible for your brain to think outside of the box. Why? Because it's not how the brain is wired. It basically means asking a neuron to fire that doesn't even exist. So thinking outside the box is actually a misleading term, because the brain cannot think outside the box. So there's nothing outside the box except for more boxes. So the trick actually is to think between boxes, and maybe to connect boxes, right? So let's think outside of the box is the word term. So let's translate this to generics. So we all know generics from Java, right? They've been there. I mean, they're a bit more strict sometimes, we feel, in Kotlin. And maybe you use it probably in the very same way as you use in Java. But why not put it into the next level? Another thing that I hardly see developers doing is implementing reifieds, like inline reify generic function. And they look really magical in the beginning, right? If you read one of those. But don't be afraid. I show you some that we use. Here's from JSON that you can call on strings. We use this in tests. So let's assume we have something like Jackson, but it could also be JSON or whatever you have. And it will allow me to load a class from a string. And without knowing about any details of this. So here's an example. Like, we have this JSON file, and I just declare something like API entity wrapper, and I call this directly from this file. So this So there's even a file loading behind this like here that I didn't show you. So but this reads so nice in my test, so they're very helpful. I show you another one. Maybe you're an Android developer and you lose like on a bundle like put string, put int, and all of this. There is no put enum, as you probably know. So why not creating an extension function in bundle? That's easy, right? That you use. But also the key. I mean, I put like one enum in there. So why not have a like key generation inside? And my colleague suggested this. So we put like make this whole thing inline reified. And there's like a key function that just used the class name. And I could call, hey, on every bundle, hey, put this enum in. And everything is handled internally, right? I don't have to think about like the key or something like this. In some cases, dangerous, but you can put in the key. The key is just like an optional parameter here. But very powerful. So how do we get there, right? How do we start writing these kind of codes? Habits are the thing, and I mentioned this a bit earlier. Habits are the internal, the drivers of our brain. So every time something happens on auto mode, that's actually because we use a habit. And these are basically neural connections that develop because you repeated something in your life. There's actually a really nice book about this called, I think, called Mini Habits. We all have this problem that like going to the gym is hard, right? Exercises, and we have to overcome our brain that tries to convince us not to go. And that book, Mini Habits, said, try to do one push-up every day. It is very easy. There's like no hesitation of doing one push-up. And most of the time, a full workout will get out of this. But at some point, after like a few days, maybe weeks, your brain just is in auto mode. It will do that push-up, right? You don't even think about it anymore. And this is when things evolve. So habits are also what you want to have for these kind of things. So how do we get on there to that hill? Unlearn, right? Build new models. Don't look through the old lenses. Then let's start connecting these boxes and then practice. And with this, you will change your habits, like make it a habit. The problem is, and let's go back to like people in history, Mark Twain said, nothing so needs reforming as other people's habits. And you could even put this as an answer by Ben Franklin. You tell me, I forget. You teach me, I remember. You involve me, I learn. So even if you change your habits, how do you get your colleagues to follow you, right? So that's actually very easy. And there's neuroscience given the answer. When your brain expects a reward, you're much more likely to pursue the new routine. So how do you get your colleagues a reward of like adapting to this more advanced Kotlin? You have the pull request, right? Like say something like, hey, great job, awesome. Like there's like full articles how to do like good pull request reviews. For example, one thing that I love that we adopted, like I adopted everywhere, never reject the pull request. Because you're kind of rejecting the work, right? So rejecting means like ask for changes, for example, on GitHub. Don't use it. You just don't approve. It means the same thing, but it's something different for your brain, right? Don't make it negative. So, and if you want to make it positive, you actually help developing these new habits. And hopefully, at some point, we can unlearn this Java and we get to this 100% Kotlin, and you will be on that hill. And I think we're pretty good in time. So thanks. As said, I'm working for SoundCloud. I hope you all have the app, and we're in Berlin. And check out if we ever have jobs open again.